Welcome. In this lesson, we are going to continue talking about atomic structure and specifically about excited state versus ground state atoms. In order to do this, we need to take a look at some history, and in particular, Niels Bohr. Bohr came up with his model of the atom, and we've already talked about how this atom looks, but now we're going to get into the experiments that he did to come up with his model and some of the observations that he made. So what Niels Bohr saw was when you expose atoms to energy, a unique line spectrum, or spectral lines, of that element are observed. This is a spectrum that contains specific colors or wavelengths. Unlike a rainbow, a line spectrum is not continuous. And we can take a look at one right now. So in this diagram, we have a tube filled with hydrogen gas, and it has electricity flowing through it. And that's going to give some energy into the system. And what Niels Bohr found was that light will come out of this particular system, and if we put it through a prism, the light wavelengths that are coming out will separate into individual wavelengths. And for hydrogen, we get these lines at different wavelengths, and this is called an emission spectrum. And if you do this for other elements or other compounds, most of them will have an emission spectrum, but they'll have slightly different wavelengths, and it acts like a fingerprint for different atoms and molecules. So Bohr, if we take a step back and think about the structure of an atom, Bohr said that the electron can only orbit in defined orbits, and each path is a certain distance from the nucleus, and each specific orbit has a specific energy. And shells that are close to the nucleus have low energy, and as we move further away from the nucleus, the shell's energy increases. And we label each of our shells with a principal quantum number, or n. And they start from 1 in the middle and go out to 7. So to explain the spectra that we're seeing when we excite hydrogen, Bohr had to come up with a hypothesis. And his hypothesis was that the electrons that are in the orbitals jumped to a higher shell when the electricity passed through the tube. So we put some energy in, and the electrons will move from inner shells to outer shells. And what we call this is the excited state of an atom. So if we have any electrons that are moving from a low energy to a high energy state, they are excited. In order to move from one shell to another, the electrons have to absorb a very specific amount of energy, which we also call a quantum of energy, or quanta if there's more than one. So that's kind of neat. Our electrons are able to move in between shells. However, once those electrons are out of the ground state and in the excited state, the atom is not stable. The ground state is the most stable form of the atom, and if we're in the excited state, the atom isn't as stable anymore. So in order for the atom to be stable again, the electrons have to go back to their original ground state. And when it does so, when they move back to their ground state, they release the energy that they absorbed before. And energy can come in lots of different forms, and one of those forms is light. So we can release something called a photon of energy. Right? So as we're going from a high energy orbital to a lower energy orbital, we're going to emit light. And that's going to be a very specific type of light and a very specific wavelength of light. And this helps us to really explain the specific color bands or spectral lines that we see in the emission spectra. And an important concept that's happening here is this conservation of energy, where the energy released equals the energy that was absorbed. So we absorb energy, our electrons move from one shell to another, and they're in the excited state, which is unstable. When they return to the ground state, they release that energy that they were absorbed, and that can come in the form of light, which we see in spectral lines. So we can do a couple of practice problems here. When an excited electron in an atom moves to the ground state, the electron, right, we have lots of possibilities here. So if we think about what's going on, we have an electron in the excited state, and it's going to be moving back to the ground state. So in order to do that, right, we have high energy to low energy. That means we have to emit energy as we go from a high energy state to a low energy state. So if we take a look at our examples here, absorbs energy is going to be ones that we can eliminate right away because we only absorb, if we absorb energy, we'd be going the opposite direction. Emits energy as it moves to a higher energy state. That doesn't seem quite right because we can't emit energy as we're going into a higher level, so that leaves us with D. Emits energy as it moves to a lower energy state, which is exactly what's happening. So as we move our electron from a high energy state to a lower energy state, we're going to emit some light. Okay, and for our second example problem here, an electron in the sodium atom gains enough energy to move from the third shell to the fourth shell. The atom becomes, right, so here we want to really be careful with what we're reading and say, okay, so the sodium atom, we have sodium, it's got an electron. Going from the third shell, to the fourth shell. So we're moving from a lower energy level to a higher energy level. The electron isn't leaving the atom, it's just moving to a different orbital. So, right, we're not losing an electron, we're gaining an electron, so this isn't going to be an ion. We're still going to have the sodium atom. Except now, because we have electrons in higher energy levels, it's going to be an excited atom, right? So we have an atom in the excited state, and we're not in the ground state because we put in that energy and we know that the electron moved. Okay, so that's it for this lesson. Here we talked about the Bohr model again, and how electrons can move from the ground state to the excited state with an input of energy, and how when they go back from the excited state to the ground state, they can release energy. And we can see that in some cases in the form of light, which is a footprint for different types of atoms. Good work today. See you next time.